So,
We can use a calculator.
okay, so last time, let's go through this. Learned how to find determinants and matrix and inverses of 2 by 2s. Today we're going to talk about determinants and inverses of 3 by 3s. All right, and the way we do that is this. So here I have a 3 by. In order to find the determinant, what we're going to do is this. It's pretty straightforward. It just requires a little bit of, care. So here is my 3 by 3 matrix. What I do is I just reproduce or I clone the first 2 columns to the right of the matrix, just like this. So no math at all. Just copy over this column and this column over to the right side. Then what you want to do is you want to find the product of the respective diagonals. Okay, which diagonals are we talking about? Well, here. You draw a diagonal this way, right? And look at what are the numbers on this diagonal? It's A, E, and I. You multiply those with each other. Then you go to the next diagonal, B, F, and G. You multiply those. Then you go to the next diagonal. You multiply those, C, D, and H. You now have 3 numbers. You add those to each other. Okay? So now we did the diagonals in that order. And remember, this direction is always the principal direction. Remember, like this is how we get the main diagonal? Yeah. Right? So it's always like this is the first direction. Then you do the same thing in the opposite direction, going from right to left. So this diagonal here, I multiply C, E, and G, but now I need to subtract that one, and then I go to the next one, A, F, H, subtract, B, D, I, subtract, and that's it. Okay, so let's do one. Let's do this one. So here, we're going to do -3, 1, -1, 2, -1, 4. All right, and what we're going to do is this first diagonal, so this is going to be determinant of A. On the first diagonal, I have -3 times -1 times 0, plus second diagonal, 2, 2, minus 1, plus 4, 1, 4, minus this diagonal. Okay, so now when I'm done in the opposite direction, I have to subtract. So minus 4 minus 1 minus 1. I do minus -3, 2, 4. And then minus, so you see what I'm doing? Instinctively, I put the negative here first, then I go to my matrix in order to get my new numbers so as not to confuse my negatives, right? So here it's 2, 1, 0. All right, now what's left is to just do the combining. And of course, you don't have to write it out in this much detail every single time, right? You could just do a lot of mental math. So yes, I'll talk about calculators in a minute. So 0 minus 4 plus 16. Here, minus 4 plus 24 minus 0. So that's here -8 plus 16 is 8 plus 24. Determinant of A is 32. That's all. Let's do this next one, but without writing out so much. So reproducing the first 2 columns. All right, determinant of A, I'm going to write it this way this time. Okay, first diagonal, look at what I do. I multiply in my head. 3 times -1 times 5, that looks like -15. Plus 4 plus, how much is that? 0. I love it when I've got the zeros. Then the opposite direction, it's going to be the negative. So I put my minus first. Then I go to my matrix, it's 0. Minus first, then I go to my matrix, 2, 8, 24, minus negative 10. Even now, at this point, when I'm doing this by hand, I draw the diagonals. I actually draw the diagonals because it's too many numbers without drawing them, right? So finally, it's negative 15 here, plus 10 is negative 5, plus 4 is negative 1, minus 24 is negative 25. Okay? Now, let's recap what we've learned so far. So far, we've learned how to work with 2x2s and 3x3s. For the 2x2s, we learned how to find determinant and we learned how to find inverse. For the 3x3s, we just learned how to find determinant. And we did all of these without a calculator manually. You will be required to know how to do all 3 of these manually. Okay? Next, we're going to learn how to find the inverse of a 3x3. There is definitely a way to do that manually, but it's a very long and arduous process, fun but long, and I'm not going to teach you how to do it manually. The only way is with a calculator. I'm only going to teach you how to do it with a calculator, which means you will have to do these 3 manually, but you will absolutely need a graphing calculator to do this one, the inverse of a 3x3. Okay?
And what about a 2x1?
These are the only ones we're going to do. Okay. So I messed up. I confused you guys with my other class, and I thought you guys still had the TI-84s, so I left this here. So these directions go for TI-84 and under, but the TI-Inspire, I'll show you how to do it on the TI-Inspire. Before we go into the calculator, let's do this determinant manually, right? How did we find determinant of A? That's the inverse, but the determinant is this minus 56.
It's always subtracting. Right?
Always subtracting. So it's negative 66. So on the calculator, here's what we're going to do. You're going to go into menu. And because this is menu driven, there are lots of, it's very, very user friendly. Okay. So here in menu, number 7 is matrix and vector. Do you see that? So hit 7. And now look at this. You have create transpose determinant. Because we're looking for determinant, hit 3. And so now it says, what do you find the determinant of? Inside here, go to menu again. Go to menu again. Number 7. Let's create number 1. Number 1 again, because we want to create a matrix. And it asks you for the dimensions, in which case it's a 2x2. So press enter. Isn't that cool? And now we're going to put in our values. I use tab when I'm doing it, and when you do tab, it goes across the rows and then down the second row and then down the third row. So I do 5 tab, 7 tab, 8, and then -2. You could also press the arrows to maneuver, and then press enter, and there you have it. That's the determinant. Yeah. Okay?
Oh.
Yeah.
Okay, I got it wrong. I put 2 instead of 5.
Okay. So,
Okay.
huh? Yeah, doing it manually for, okay,
Well,
it's
unless it's a
so
big
not
one.
worth it to
Unless it's a
plug it
big
in
one.
for this, right? But let's do another one. I thought it was
Like
raining
that
again.
one would be the most.
Okay, let's do this one. So, menu, 7, number 3, And now inside, let's put a matrix. Menu 7, 1, 1. And this time I want to do a 3 by 3. And if you go on the arrow here and press up, you could get your 3 by 3. Okay.
Wait, what arrow?
The menu over there, like that.
I see it.
You see
Oh,
it?
but it's not, it doesn't say determinant anymore.
Oh, did it go away? All right, I'll do it. So let's say you messed up and you put in your matrix first. Then you could go to the left of the matrix. Like you could put your cursor to the left of the matrix and just insert it. Let me see if we could do that. And then you would have to like highlight.
Yeah.
You know, you could do Control X and Control V, right?
No way, actually.
Yep.
That's really
You
cool.
can highlight on these calculators something, and then you could do Control X and Control V. So we're going to put our matrix in. 8, -2, 1. I'll be right there.
No, wait.
6. The process is very different in the 84s. Okay, so it's -108. All right, and you could still, you could still get like your 0 and your this and your that. Okay, all right. So on the test, you will have 2 parts. On the non-calculator part, I might put a determinant of a 3 by 3, and then I might put another one on the calculator part to do with a calculator, right? I want you to know how to do both ways.
Wait, you mean the other way around? Right.
Determinant of a 3 by 3, you have to know how to do both ways. So I might put one on the non-calculator section to do by hand, and I might put another one on the calculator section to do with the calculator. Okay, so now we're gonna, okay, so here it says find the determinant, then find the inverse. I'm going to show you the inverse first. So for the inverse, the process is the same, but first you put in your matrix. So let's do menu 7, create a matrix, and I want this to be a 3 by 3. Okay, there is no function for inverse. So just put this here, and then let's put in our matrix -1.
It's again the determinant is gone.
Yes, because I'm looking for inverse this time. I'm not doing determinant right now. Huh? Yeah, we just plug it in. We just did menu, create, matrix. Once you've created your matrix, exit out of the, so press the right arrow button to bring the cursor to the right side of the matrix. And now what you're going to do is raise this to the power of -1. Enter. There's your inverse. Yes. So you remember how A inverse is like, this is the notation for inverse, right? So that's how we do it. So A inverse is equal to 1/3 negative, -1/3, -2/3. See if your matrix was input correctly. If you're even off by a number, your determinant will be different, hence the inverse. Okay, so that's A inverse. Yes, please. Now, please make sure that you put your inverse in fraction form. Okay, so now suppose you want to go back and you want to find the determinant of this. Please don't retype your matrix, okay? So pressing the up arrow once and then once more, it highlights this matrix. Press enter, now you got it back, and just edit. So delete, go to the right of it. Okay, so you know what I want to do actually? Can you highlight your matrix?
I don't know.
Do you know how to highlight?
Just double tap.
You can do that. I'm having.
Yeah. Oh, I got it. You should do like a triple 3 times.
Yeah.
Oh, yeah, triple.
Just keep tapping. And now look, you could do Control X. And it cut it for you, right? Control X. So now do menu. Number 7. Number 3. Determinant. Inside, Control V. Voila. That's the determinant. 9.
Oh, do you need
Okay. Okay. All right. So go ahead and find the inverse first of this one, please. Not the determinant first, but the inverse first. Go. For this one, we said singular, which means no inverse. Right, and the way that you get no inverse is when determinant is 0, right? Why does determinant of A equals 0 mean there is no inverse?
It just does.
Why though? For a 2 by 2, how did we find inverse? What do you do to the determinant? What do you do to it though?
Well, because when you multiply and get the determinant,
Uh-huh.
it's 1 over 0.
Right.
Which makes it undefined.
Exactly. Once you get your determinant, in order to find the inverse, you have to do 1 over the determinant. And if the determinant is 0, then it's 1 over 0 and it's undefined. Okay, so take a look at what we've got here. It's a 3 by 3. I'm sorry, it's not a 3 by 3. It's a triangle, right? It's a triangle, and now we need to find the area of it. So what is back in the day? What did we learn? The formula was 1/2 base times height. So that means if I had my triangle like that, right? And if this was the base, okay, what would the height be? Where is the height? In the middle, going from where to where? Top. Okay, so from the opposite vertex to the base. And what's the condition? What does that line have to be with the base? 90-degree angle. Okay, it has to be perpendicular. That's the height. It's not just any line drawn from the vertex down to that. So now we come here. Okay, suppose I want to make this the base. Then, the height has to be perpendicular to this, right? But then how do we find, look at this, like nothing is a straight line. So how do we find it? It's a pain in the neck to have to find like the correct line which makes this 90 degrees, and then to have to find the point of intersection and and the height and the distance and so on. Instead though, we could use a matrix. The way you could use a matrix is this. So what we're going to do is I'm going to call this matrix V for the vertices. Okay, you could call it matrix M, whatever. Just don't call it A because let's use area. Let's use A for area. So this is going to be my vertex matrix. So we have 1. In here, I'm going to put the 3 vertices. Now, 1, 6, and then 2, 0, and 6, 4. You could put them in any order. You could do vertex A, B, C, or C, B, A. You can put them in any order. I'll let you know later where that makes a difference. It doesn't make a difference in the value, right? And it shouldn't make a difference in the value because if you look at the triangle, sideways, does the area change? It doesn't. Okay, so now this is not a useful matrix to me though. This is, what dimensions is this? A 3 by 2, that's not a good matrix. A 3 by 3 is a good matrix. What am I missing here to make this a 3 by 3? Another column. So you know what we do?
Put zeros.
Nope. Then everything will be zeros if you put zeros. You put ones. Why ones? Because zeros would make it 0. Okay? It's always ones. No matter what. Always ones. Okay. Now, what I want to do is I want to find the determinant of this.
Does it always have to be a 3 by 3?
Yes. Because 3 vertices, so 3. Okay, I want to find the determinant. So I copy over this column here. Okay? So I get 0, 36, 8, minus 0, minus 4, minus 12. So negative 16, positive 8 is how much? Negative 8 plus 36.
Is 28.
Sure, we'll go with 28. Okay, so the determinant is 28. Okay, suppose you had put in your vertices in a different order. The only difference that would have made is possibly you would have gotten negative 28 for the determinant. Okay, now this is the determinant. This is not the area of this triangle. The area of this triangle is going to be half of the absolute value of the determinant of V. So it doesn't matter if you put it in a different order. If you got the negative determinant, you end up taking the absolute value anyway.
Oh, so that's the absolute.
That's the absolute value, right? So we're mixing symbols here. So it's half of 28, 14. Yep, it is really cool. Okay, and you recognize that area must be positive, right? Okay, so that's that. So now this is the homework for this section.